Section 2. Pressure and surface area. Pressure increases as area decreases, and the opposite also applies, which means that pressure decreases as the area increases. Let us conduct a practical exercise to examine this relationship more closely. 1. Get a rectangular block of dimensions 60 cm by 40 cm by 10 cm. 2. Measure the mass of the block and calculate the weight of the block. We can now find the area of the respective faces. 1. 60 cm by 40 cm. 2. The face 60 cm by 10 cm. 3. And finally, the face with 40 cm by 10 cm using area equals length multiplied by width. Using the formula for pressure, equal force divided by area, calculate the pressure in each case. We will realize that the face with the greatest area gives the smallest pressure, while the face with the smallest area gives the largest pressure. Now let us consider further applications of this principle in our daily lives. For example, a sharp knife will cut an object better than a dull knife. Since the area of the edge will be less in the sharp knife, the pressure will be greater at the edge. A nail has a pointed tip, which means a small surface area. Hence, when a force is applied, we will get a great pressure at the tip so the nail can penetrate the board when hammered. Let's carry out an experiment to determine the pressure exerted by an irregular object. Pressure lab. Aim: to determine pressure exerted by an irregular-based object. Apparatus: graph paper, piece of stone, triple beam balance. Procedure: 1. Outline the face of the stone on the graph paper. 2. Determine the approximate area of the face by counting the number of centimeter squares. 3. Convert from centimeter squared to meter squared by dividing 10,000, since we work in base units at all times. 4. Measure mass of the stone using the triple beam balance. Convert mass into grams to kilograms by dividing 1,000. 5. Calculate the weight of the stone using weight equal mass times gravity, or W equal mg. Results and calculations. See table. Observation. Precautions. 1. Avoid parallax error when reading the scales. 2. Ensure the balance has no zero error. Pressure in fluids. Fluids are substances like liquids and gases, which are capable of flowing. Pressure due to fluids is given by density times acceleration due to gravity times the depth or height of the fluid. So, P equals rho GH, rho equals density, G equals acceleration due to gravity, H equals height or depth. Unit is Pascal or PA. Let us consider an example. A scuba diver is 100 meters below the surface of the sea. A. Calculate the pressure exerted on the scuba diver by 100 meters of seawater of density 1,150 kilogram meter cubed. Use the value G equal 10 Newton per kilogram. B. Also, calculate the pressure when the scuba diver goes to a depth of 200 meters below sea level. pressure in fluids will be dependent on the density of the fluid and the depth. Since gravity and density remains approximately the same at a given location, the pressure on the diver increases with depth.